Thank you very much. So yeah, so title of my talk is to basically talk about the India's mission to Mars, that is the Mars orbiter mission. So you can see this is an artistic view of the Mars orbiter, and this is the half view of the global Mars. So let us see it in detail. So before we get into the detail of Mars, let us see where is Mars in our solar system, where it is located. So you see Mars is the fourth planet, and these four planets are called as the terrestrial planets. So terrestrial planets means they have a rocky surface, as well as these planetary bodies have undergone differentiation. So you will see crust, mantle, and core with respect to these terrestrial planets. So Mars has a crust, it has a mantle, and then it has a core. There are several mysteries regarding the present day status of the core, whether it is molten or whether it is solidified. But yes, at least we know that it has got differentiated. So remember that it is the fourth planet from the Sun. And when I compare this planet with Earth, what do I see? That Mars is approximately half the diameter of Earth. It rotates in almost same time, around 24.6 hours in case of Mars and 23.9 hours in case of Earth. One day is also 24.7 hours. But what are some peculiar things on Mars is that you see the gravity. It is 0.4 times that of Earth. So it is around 3.7 meter per second square. As well as you see the orbit. It takes around 1.88 Earth years to make a full orbit. And the distance of Mars from Sun, it is approximately 228 million kilometer, which is around 1.5 AU, whereas Earth is at 1 AU. As well as from several orbiters, landers, rovers, we know the present day temperature pressure conditions on Mars. So at present, we call Mars as a cold and dry planet. But in the past, we have some evidences that tells that Mars was once wet and it was also warm. But here you see the summer afternoon temperatures in the equatorial locations. They often go higher than 0 degree and the peak is around 35 degrees Celsius. Whereas the lowest temperature is around minus 43 degrees Celsius. So it is generally very chilling on Mars. That's why it is called as the cold and dry. And this has got something related related to the axial tilt of Mars, which is currently 25.2 degree. But since you know that Mars has got very small moons, I hope if you have attended my previous lecture, I have told that Mars has got two moons, Deimos and Phobos, and because of the very poor gravitational force exerted by those moons on Mars, the tilt of Mars is very chaotic. So it goes around 50 to 60 degree and then it comes back again to 15 degree. So that type of chaotic obliquity of there has been seen on Mars. And how does Mars look like? When you see this first global image that was sent by our own Mars orbiter mission, this is how Mars looks like from orbit. And this is how Mars looks like from a lander. So this is the first color image of Mars that was returned by Viking 1 way back 4 decades back. So, and then this is another view which is from Earth, which was taken again 4 decades back by an observatory on Earth. It is Lowell Observatory, somewhere around 1988. So what do you see as a common feature in all these three images? That Mars appears to be red. That is why we call it as a red planet. But this red planet and then this appearing like this, only rocks, I don't see any ice, I don't see any water currently in this image. So why are we looking at this planetary body at all? Why it is important? Is it having any mystery? Or studying Mars will help me understand Earth in a more detailed manner? Just in a similar way, where is Earth? Earth is this tiny dot. But you see, we are living on this tiny dot. So in the same manner, there may be several mysteries, several intricacies which is there on Mars, which we have to understand to using the orbiters, landers, and rovers to get more insights on how this planetary body evolved. As I told you, currently it is cold and dry, but in the past it was warm and wet. So how it transitioned from warm and wet to cold and dry? What different happened on this planet that such a global scale transition happened on Mars? So these are the things that we have to understand. So we will again talk about why we study Mars in subsequent slides. But the planet that we call as a red planet is actually not completely red, and that we came to know when one of the rovers sent by NASA to Gale crater performed drilling operations. So when it drilled the surface of Mars, what you see here are the drill holes. So we see multiple colors. So then what do you think? Is Mars really red, or it has got multiple colors just like that we have on Earth? So you see, the moment we choose to explore a planetary body, we come to know several things which we do not know. And when we look in more detail, we will see that, oh, some part of it is matching with the Earth. But then how it is different from Earth? So these are the very preliminary questions that come to mind of a young scientist or a young researcher that motivates us to look further and look in detail. So coming back to the primary question, why we study Mars? So what we know, and this is all what we know from the orbiters, landers, and rovers that have been sent to Mars. What we know that 4 billion years ago, Mars also had a thick atmosphere. So when I say thick atmosphere, it means Mars had sufficient, or you can say optimum pressure temperature conditions, due to which sufficient water can flow on the surface. But what we don't know, whether that water and all the atmospheric parameters, all the atmospheric gases that were there in the atmosphere, whether they provided any hospitable conditions, whether there was life. And also, we don't know how this planet evolved into a cold and dry desert. What happens on this planet that it became cold and dry from a probable life supporting warm and wet planet? So you see, maybe the warm and wet planet was probably life supporting, but then it became cold and dry. Then what else? If we study Mars, so as I told you that we know information about 4 billion years ago. Do we know places on Earth where we have access to 4 billion year old materials? We don't have, because Earth has got several phenomena happening. Like there is tectonic, there is rainfall, many other phenomena are there, which is throughoutly it is resurfacing the planetary surface. But in case of Mars, we don't have that. We have many locations where we can get access to these old rocks and materials. So if we can analyze those old rocks and materials from Mars, we will come to know how Earth has evolved and what was Earth at that time. As well as we will come to know, if you are looking at these features that are resembling flow of water, we will be able to address for how long there was water on the surface of Mars, what was the timing, and in what volume, whether there were seas and rivers just like what we have on Earth, or whether this water was in very small quantity. And if that water was there, if Mars was warm and wet, where did this water go? You see, this is a very fundamental question. If water was there, where it has gone? As well as if we can look at the atmospheric samples, which will give us further detail on the formation and evolution of Mars. As well as we will come to know why Mars atmosphere became thin as time has passed. Why not we see 1 bar atmospheric pressure on Mars? Why the pressure is so less? And to address some of these questions, many missions, comprising of orbiters, landers, and rovers have gone to Mars. You see, it is a long list. And we cannot talk about all of them. There are so many missions that have gone to Mars. There is our own Mangalyaan. You see, it is here in this time frame, 2010 to 2019. You can see Mangalyaan 2 also over here. So it is an exciting time where we are also planning about Mangalyaan 2. And then there are many rovers and landers that have landed on the surface. So when I say landed, it means that they have given us in situ information. From orbital, we get a large scale information, but from when we land and when we explore the surface, we come to know about what is actually there. We get to know about the ground truth. What we inferred from the orbiter, we are going to test it by landing on the surface, by roving on the surface. And you may be also knowing that one of the recent rovers that were sent to Mars, that is the Perseverance rover, has got a helicopter. So it is flying on Mars. So in that thin atmosphere, there is a helicopter which is scouting the surface of Mars. So you see the technological advancements. Not that we can fly helicopter only on Earth. We can also fly helicopter on Mars, even in the thin atmosphere. So now you think the type of data that we'll be having. We are having really very good, fantastic data with respect to, when I say data, I mean images, spectroscopic data, which tells you about the chemistry, the mineralogy of the rocks. Then we have subsurface data. We have information about the atmosphere. We have meteorites from Mars. Many rocks have come ejected from Mars and they have landed on Earth. And these meteorites, these rocks have been recovered. So you see, we have fantastic amount of data that is there. So there's a great opportunity for the younger generation to get into exploration of Mars. So what we have learned from those data sets as of now, what we have learned. So one thing that we see to understand very clearly is that Mars, the early Mars that we call as, is supposed to be having an atmosphere as well as a core that could have generated magnetic field sufficient to shield the atmosphere. Shield the atmosphere from the solar wind, the energetic particle that is coming from sun. So the atmosphere could remain preserved. And when the atmosphere could remain preserved, the pressure temperature conditions were optimum. So that is why in the past, there were several locations on Mars where water has flown on the surface. And how do we say that? We say that on the basis of, we see river-like channels on the surface of Mars. We also see features that would have formed in an environment which required water, like clay minerals. So these are all there which have been seen in the early Mars. But as you know, there are studies which says that the core solidified or after a certain amount of time. As a result of that, the magnetic field has died. And as magnetic field has died, the atmosphere got exposed to the energetic particles that were coming from sun. And as a result of atmospheric etching, the atmospheric particles were finally removed. So when it was removed, the atmosphere became thin. It became 1/100th of the atmosphere that we have on Earth. So when you have a thin atmosphere, you essentially what will happen that you cannot trap the radiation. So the temperature balance could not be sustained. And then thin atmosphere cannot exert that much pressure. So we know that for water to flow on the surface, it has to be slightly above the triple point, the point at which solid liquid gas are stay in equilibrium. So but the conditions are, as we just discussed, conditions are not very supportive. The pressure temperature conditions are very low. So today Mars, if you see, today Mars is dry and today Mars is cold. So this is, and this, the time scales between these are, this probably happened around 4 to 3.7 billion year time scale. This conditions were there, and then when we transition from this to this is there since last 3.5 billion years. Since last 3.5 billion years, Mars has almost been, thin, with a thin atmosphere. The temperature pressure conditions are very less, and these geological episodes, they are actually defined as some particular geological episodes. For example, the period where water activity was there is called as the Noachian epoch, and the periods in which Mars became cold and dry is a combination of Hesperian and Amazonian epoch. Okay, and then we know that Mars, all the data sets had shown us that Mars has a diverse geological history. So you see the overall span of geological timescales. You can see there are different epochs, what I just told you, and in those different epochs, several different phenomena have happened, like volcanism, fluvial activities, mineral formation, aqueous environments, alteration. So all these different processes have happened on Mars, and if you see the latest Mars, or you can say the younger Mars, so these are some of the features that are still operating on Mars. Like there are features called as recurring slope lineae, there are gullies. So these features are still, forming on Mars. And then, as we all know, that Mars has got very high wind speed. So aeolian landforms are also forming on Mars in the present day. So despite knowing all this, Mars continues to surprise us. You see, these are some of those features that are currently happening on Mars. You see, this is the recurring slope linear that I was talking about. You can see in these animations that features are growing and then they are contracting. You see this one example of dust storm, which is taken, this image is taken from when you're standing at the surface of Mars from Gale crater. Curiosity rover has taken this image. You see, within few days, sol refers to a day on Mars. So within a few sols, the entire view becomes hazy. That is, it is covered by dust. And you see several other phenomena that are happening currently on Mars. And these phenomena are very important because if you are thinking about a mission which involves landing on Mars, we have to have a very good understanding of these active events that are happening on Mars. Then only we will come to know that our lander and rover and our instruments are safe. So now let us just see the scientific rationale for the India's MOM Mars orbiter mission and what can be done, what could have been done using the Mars color camera. Why we needed a Mars color camera around Mars. So this is one of the instruments that was there on the India's Mars orbiter mission. So you see, I am putting some examples here. You see, this is a comparison between the Viking and Mars Global Surveyor missions. So they have a timeline around time difference of around 20 years. So if you look at these rectangles, and this image is from the Viking and this image is from the Mars Global Surveyor. So when you compare these rectangles, you can see the feature which is shown in this rectangle has either disappeared or it has changed its shape. So what are these dark color patches? First of all, these are basically dust cover. So you see this particular dust cover, it has grown in 20 years time. If you see this particular dust cover, dust feature, it has again, the shape has changed. And see here, it has almost disappeared. Then you see here also, there are many locations where we see new dust deposits forming. Okay, and this happened with very small time scale. You see the Martian year is same. When we talk about a year on Mars, it is defined MY, Martian year. So see, Martian year is same, but you see, within a few days time, dust deposits have covered this area, Mare Serpentis. And then here also you see, before storm. The storm means dust storm, as you have seen in one of the images that was taken by rover. So there is active dust storm on Mars. And I'm sure that there are classes which will tell you about the dust storm happening on Mars, the wind related activities on Mars. There you will get more detail about how it happens on Mars. But just for the sake of comparison, you can see I have drawn the line which corresponds to the extent of dust. But then after the storm, you see the dust extent has increased. Here also you see we are comparing two images of the same Martian year. Here again dust has appeared, and here also you see dust has appeared using the recent data sets from the EMM, that is the orbiter sent by the UAE. So you can see several phenomena are happening on Mars, and this has been observed from last 4 decades that the surface features are changing. But we were not having a camera during the time when MOM was launched that could give us global image of Mars, that too in a color mode. Because if you want to study what is the status of this feature in the 2010-2020 time scale, you should have a camera in the orbit which can take global images. So there was no camera at that time. For that purpose, MCC was conceived. The idea of an MCC was conceived that it can take colorful view of Mars, that too in a global mode, as well as localized mode, but global modes were very significant. That's why there was a dire need of a camera that could basically monitor these surface changes, especially on a planet where if dust storm happens, it can cover the entire planet in a few days time. And you see, when you if you know about one of the rovers, the Mars exploration rovers, Opportunity rover, it died actually because of the solar panels that were covered by the dust. So you see, monitoring these events is very important. Then only you can ensure that whatever missions you are going to have is going to be a successful mission. You see the entire dust storm, the one which is shown in the brown color, the one which is coming in the animation, has covered the entire planet. And as a result of that, the solar panel of opportunity got covered by dust. It blocked all the sunlight and opportunity could not recharge. And in addition to these global events, if you want to monitor, suppose Gale crater, so this is the landing site of the Curiosity rover. So if you want to monitor the dust activity at this site, you need a camera that can basically look at such regional scale and differentiate between dust and non-dust areas. So this is one image from the MCC itself. So you see very clearly MCC is showing that after nearly 4 decades, dust patch has again appeared. So now if I want to analyze the area outside Gale crater, it is very challenging because we see from the recent MCC data that there is a huge patch of dust. So we cannot land in that area. It cannot be chosen as a landing site for a mission or ISRO mission in the future. Coming on to the other instruments that were there on Mars orbiter mission. So there was a sensor which was dedicated to detect methane on Mars. So why that was conceived? It was conceived because if you see the results that came up from the previous missions, for example, this one is showing the result from the Curiosity rover. So what it showed that there is a seasonal variation in the methane that is there on Mars. The amount is pretty less, but then there is a diurnal variation. So then there is a mechanism that is feeding or again extracting methane from Mars. You see, and then the results, you see, 2012, no methane, or it was less than 5 ppb. Then 2013 again, no methane. Then 14 again, it detected 10-fold increase in the methane, around 7.22 ppb. Then again in 2018, it was inferred that there is a cyclic seasonal variation in the background level of atmospheric methane. And then in 2019, largest concentration of methane was detected. So it was very important because of these results and several other results that were there. It was very important to send a sensor to Mars, which can basically detect this methane from the orbit. And here you are at one place on Mars. From orbit, you can look at the global Mars. There are some constraints related to the sensitivity as well as the amount of methane in the atmosphere. But if you do not attempt, you will never come to know. So to address that, a methane sensor was planned. Then, as we have just discussed, that Mars was once warm and wet and then it became cold and dry. How we come to know about that? We come to know about that. Just one example is shown here. There are several other ways. So showing the isotope of argon. So what do you see? When Mars formed, typically 4 billion years ago, there was argon 36 in the atmosphere. But as time passed, the argon 36 reduced. At present, you see the argon 36 value is almost close to 0. What it is telling us? It is telling us that the lighter isotope of argon, which is argon 36, has actually escaped over time. So when we come to know that something has escaped, it means an escape phenomena has actually happened on Mars. And that can be best explained by a phenomena that is called as sputtering, where the solar wind particle will come and hit the particles in the atmosphere, and your particles from the atmosphere will be etched and it will be thrown tangentially at a very high velocity. So that will happen over time and it will finally reduce the atmosphere. So this was measured by Methane as well. Methane measured the Mars atmosphere loss. And then Curiosity also updated in 2012 that the hydrogen, in compared to deuterium, hydrogen has isotopes of deuterium, and heavier one is called as deuterium, and this is hydrogen. So if you measure the ratio of D by H, that is deuterium by hydrogen, the ratio is very large. And how come they came to know? They analyzed those samples which were brought up from the drilling. So when they analyzed, they found that there is hardly any hydrogen. So it means all the lighter isotope has actually escaped. So we came to know that Mars has lost its atmosphere. So if we can send a photometer which can measure the relative abundance of the deuterium and hydrogen, it can provide us many new insights into this aspect. And that particular photometer is basically Lyman alpha photometer. So that Lyman alpha photometer, which is basically, it is a sort of, it is a spectrometer which will basically look at the hydrogen lines. So it basically looks at when the atomic electron transitions takes place, when from an excited state, that is from n is equal to 2 orbital to the ground state, that is n is equal to 1. So that type of measurement it can do, and it is best suited for analyzing the presence of hydrogen in the atmosphere. And this is another about the other instrument that is called as MAINCA, which is the Mars Exosphere and Neutral Composition Analyzer. So this was basically dedicated to analyze the escape processes. So what we have just seen, that there is an escape, atmospheric escape happened on Mars. So this particular instrument is very well suited to analyze the escape processes that are happening in the atmosphere, or you can say the exosphere of Mars. So exosphere is the place where most of the escape phenomena are happening, because the particles that are being targeted, they do not interact with each other in the exosphere, so they are escaping from there. So if we have an orbiter which has got a spectrometer which can basically measure the abundance of those gases in the exosphere, we will come to know at what rate and how much has escaped from the atmosphere of Mars. So for that reason, MAINCA was envisaged. So now let us see the profile of the Mars orbiter mission. So indeed, you will also agree that the mission, the Mars orbiter mission, was a real challenge. It was a challenging mission. So it was sent, the launch was made on 5th November 2013, more than 10 years from now. And then the launch vehicle was PSLV XL C25. So this was the launcher. So you can see, simply we cannot just go to Mars. And with this type of launch vehicle, you have to do several orbit raising maneuvers. Then only you will be able to, reach to Mars. So you see, upon launch, there were 6 orbit raising maneuvers on 6th, 7th, 8th, 10th, 12th, and 16th. 6 orbit raising maneuvers were performed to raise the orbit from 24,000 kilometer to 1,93,000 kilometer. Okay, so after doing this, there was a departure of the MOM spacecraft from Earth, and that departure then subsequently it went to Mars. So we will see here. So the probe traveled upon reaching Mars, it traveled a distance of, so a very big number. So that much distance it has to travel to reach Mars. So you see, it was launched from Earth and then it traveled so long distance to finally reach Mars. It took around 9 months for the orbiter to reach Mars. You can see the profile here. So you see, it has gone and then it has gone like this and then it reached Mars. Okay, so here you see, the moment satellite has reached, MOM has reached, this is how it is. These are the aerocentric orbits. So this is basically how it was orbiting around Mars. So the green circle was Mars. So you see these are the orbits. So the orbit is highly elliptical. So with the perigee at 421 kilometer and the apogee, the farthest point, at around 77,000 kilometer. And this was on 24th September 2014. So finally it was there and then it started exploring Mars. So you see, it was not a one attempt. So several maneuvers has to be done to finally reach Mars. And when you perform such maneuvers, you have to be very careful. The satellite should not escape at an orbit which is not the desired one to finally go towards Mars. So you have to be very particular in giving the commands, in the operating the engines that are on board the spacecraft, to be very precise. It has to travel the orbits, it has to cover the orbits to finally reach the Mars. And what were the scientific objectives and instruments that were there on board MOM? We also call it frequently as MOM, as Mars, short form of acronym of Mars Orbiter Mission. So the scientific objective of Indian MOM are to explore Mars surface features by studying the morphology, that is the makeup of the surface, topography, that is the undulations, and the chemistry, the mineralogy of the rocks, what these rocks are made up of. Then study the constituents of the atmosphere of Mars, including, as we have just seen, methane as well as carbon dioxide, using the remote sensing techniques, because we are in the orbiter, the instruments are in the orbiter. And then study the dynamics of the upper atmosphere of Mars, that is the exosphere, effect of solar wind and radiation, and the escape of volatiles through the outer space. So such types of objectives, you can, by reading itself, you can see that these were very critical objectives that were decided to finally, address using the instruments that were sent on board MOM. So the three domains that the instruments covered is, one was the atmospheric studies, one was related to the atmospheric studies, exospheric studies, and then surface studies. So the two instruments that looked at the atmosphere of Mars were, first one was Lyman alpha photometer. It is a photometer that basically measures the abundance of deuterium and hydrogen from the Lyman alpha emissions in the upper atmosphere of Mars. So if you can measure this, you will be able to constrain how much has escaped. So when we are specifically measuring the deuterium by hydrogen ratio, we can constrain the amount of water loss to the outer space. Because you see, one of the fundamental questions that we want to understand is, if water was there, where it has gone? And if water was there, then in what volume? And in what volume water has escaped? So to address that, Lyman alpha photometer was sent on board MOM. Then there was a methane sensor. We have already discussed that there was a lot of discussion going on around to understand the abundance of methane, whether it is there or not there. If it is there, where it is there. So to address all those questions, methane sensor, that is called as MSM, was sent on board Mars orbiter mission. But as I told you, there are several constraints with respect to the amount of methane that is there. You can see it can map its sources with an accuracy of few tens parts per billion. But to measure this, we have to ensure that this much amount is actually there or not. So a lot of critical, things are involved when you plan a mission, when you design an instrument, and when you send it on board a planetary mission in particular. Then for exospheric studies, there was MENCA, which is Mars Exospheric Neutral Composition Analyzer. So basically it is a quadrupole mass analyzer, which can analyze the neutral composition of the particles in this range, 1 to 300 atomic mass unit. And it can look at the unit, the resolution was unit mass. So for every 1 atomic mass change, it can detect the particles in the atmosphere. So it was a very high resolution analyzer. Then we had two instruments which were looking on the surface. One was the Mars color camera. So this is a tricolor camera which took images in the red, green, and blue in the visible range of 0.4 to 0.7 micrometer. And as we have just discussed, it was very important at that time to have a camera around Mars which can take global images, because we were knowing that there are several phenomena happening on the surface of Mars, but there was nothing to monitor it. So for that, MCC was proved to be very useful. And then there was a thermal infrared imaging spectrometer. We had one thermal infrared imaging spectrometer on Mars Odyssey, which is called as THEMIS, but that was there nearly 15 years before we thought about Mars orbiter mission, the actual launch of Mars orbiter mission. So it was a requirement that we again measure the areas which shows emitted radiations in the thermal wavelength. So the thermal infrared imaging spectrometer was dedicated to measure the radiation that is coming in the 7 to 13 micrometer. And this is very important, because if you can record this radiation in this wavelength regime, you can basically measure the temperature, and you can also infer the mineralogy of the surface. So for that purpose, this particular instrument was also very important and very useful. So let us see some major milestones subsequent to the launch of Mars orbiter mission. So the first orbit global view of Mars came in on 28 September 2014. This was the first global view of Mars that was taken by the Mars color camera. And then if you had followed MOM mission, you may be knowing that there was a comet that had flyby Mars. So we had to, keep our MOM in a very safe position so that it does not get affected by the tail. Basically, you can see the tail of the comet is it is of very long distance. So we had to make sure that the Mars is in a safe position. So Mars was, you can say, we safeguarded it using the Mars itself. So it went behind Mars so that it can safeguard itself from this comet flyby. Then on 24th March 2015, MOM completed initial 6-month orbit. So basically the plan was to use MOM for 6 months. Initial plan was to use it for 6 months. But you see, it not only went for 1 year, 2 years, 3 years, it basically worked for 8 years. Then after a year, exactly after a year, this scientific atlas of Mars was launched. It was released, and you can see the stalwarts of ISRO. You can see the Kiran Kumar sir here, and they had released the Atlas of Mars in just after a year. We had launched the Mars orbiter, and then the first scientific result, it was published in Geophysical Research Letters. It is a highly reputed journal which actually measured the abundance of these different atoms in the atmosphere of Mars, in the exosphere of Mars, oxygen, nitrogen, and carbon monoxide, and then carbon dioxide. So when you talk about the exosphere of Mars, or you talk about the atmosphere of Mars, definitely you will come across by the articles published by our own director, Dr. Anil Bhardwaj, director of PRL. So this was the paper that was published by Dr. Anil Bhardwaj. This is the first science result that came out from the main instrument that was sent aboard MOM. And then MOM completed its 1,000 days on 19th May 2017. So this was every century or every like when you achieve this, it should be celebrated. So when MOM completed its 1,000 days, it was considered a major milestone that MOM could achieve. And then on 24th September 2018, MOM completed 4 years in orbit. Then in July, nearly after a period of 6 years, it captured image of one of the moons of Mars, the Phobos. The Phobos is a large moon of Mars among the other moon, Deimos. So this image was captured by the Mars color camera. So you see, often I am taking name of Mars color camera. So it was a very important instrument that was sent on board MOM. So it could show us that the potato-sized shape of the particular moon, and there are some features also which we can recognize on the surface of Phobos. And then on October 2022, finally, India's MOM quietly bids adieu after 8 long years of operation around Mars. You can see from 24th September to October 22, it completed 8 years, and after 8 years, it quietly said bye to all of us. And that's how the mission completed. So what were the major recognitions? So from Aryabhatta, that was the first satellite that was launched. From Aryabhatta to Mangalyaan, you can see this was the 2 rupee note on which Aryabhatta was actually, the image of Aryabhatta was there on the backside of the note. But then when we had Mangalyaan, we had the Mars orbiter mission that was on the reverse of the 2000 currency note of India. And then Mars orbiter mission was also the particular image, the global image that was covered by the Mars color camera was also featured on the cover page of the National Geographic magazine for their story Race to the Red Planet. So this was one of the time when the global image of Mars was featured on the front page of the magazine. And the hard work of the scientists that were involved in the Mars orbiter mission was also recognized in form of the Space Pioneer Award for Science and Engineering, which was presented by the National Space Society to ISRO for successfully launching MOM and then reaching Mars on its first attempt. That is the maiden attempt we reached Mars. That's a history and it's a remarkable achievement. Not only these milestones, there was some fun activity also that was going on when MOM reached, and one of these activities was with our Honorable Prime Minister of India. He had, when the MOM has tweeted that the view is nice up here, our Prime Minister, Honorable Prime Minister has tweeted, yes, I agree. The view is indeed nice up there. So you see this type of communication. So how much prestigious was this mission? You can make an idea. And then there were other spacecrafts also that were sent to Mars. For example, Curiosity and Maven. And when MOM reached Mars, Curiosity told Namaste to the MOM orbiter. Namaste, Mars orbiter. Congratulations to ISRO and India's first interplanetary mission upon achieving Mars orbit. And then Maven also congratulated ISRO. So the team which is working behind Maven also congratulated ISRO. So this type of communication was also going on behind the scene when MOM reached the orbit of Mars. And then there was some fiction activities also going on, where there was a movie which was titled Mission Mangal. So I'm sure you all would have seen this movie for sure. And then there was a web series also termed as Mom. So all this was done to popularize, to basically motivate the younger generation and let people know in a simpler manner what were the complexities involved in the Mom mission. Then coming on to some of the that came out from the Mars orbiter mission. So you can see one example here. These are the global views of Mars which were captured by MCC on different dates. So you can see it could capture the full disk view of Mars and how the surface changes, or how different areas on Mars look like. You can very well see in these different global views. This is from the Mars Atlas that was released just 1 year after the launch of MOM spacecraft. Then, as I told you, that MOM can capture this, MCC can capture regional views, global views, as well as localized views. You can see one example here. This study was done in a Luna Planum. The area name is Luna Planum. So what it is showing is actually these bright deposits. These bright brown color deposits, what you can see here, is actually referring to the dust storm. So this dust storm basically appeared when? On October 20, 2014. And then after a few days, the dust storm has disappeared. So you see the advantage of Mars color camera. Monitor these activities which are happening at a scale of few days. And not only that, we can see these regional, we can also see large scale phenomena. You can see clouds which are there around these volcanoes, Olympus Mons. This is the tallest volcano in the solar system. You can see these clouds, the bright water ice clouds. They can be also monitored using this Mars color camera. And then this is one very spectacular view of the pole of Mars, the North Pole of Mars, which we also call as the North Polar Layer Deposits. This particular is a three-dimensional view, and at the top there is Mars color camera, and below that it is MOLA topography data. MOLA is a Mars orbital laser altimeter data, which was there on the Mars Global Surveyor. So when these two images are draped together, we can see this beautiful three-dimensional view of the North Polar Layer Deposits. So you can see, you can use MCC image to basically attribute, annotate the areas, and you can identify different areas. And when you look into detail using the other instruments, you can basically look at these different layers and talk about their evolution, how they formed, at what time scale these features have evolved. So such things are all possible using the Mars color camera data. This is a very recent publication from using the Mars color camera data set. And not only that, we can also look at we can characterize the shape of the clouds. So this is one of the cloud that is called as a Lee wave cloud, which can be seen at a higher altitude. So you can see such types of clouds can be also detected using the Mars color camera. As well as we can also observe such tails, cloud tails around certain features on Mars. This is one example from the Arcia Mons on Mars. Using the Mars color camera image, we can basically look at this particular feature. So these things are again very important, because you have to understand how the atmosphere of Mars is changing, because this water ice is coming from the polar areas, and for that to be released, we know that Mars polar cap has got CO2 ice. So if that sublimes, the water ice will be exposed, and that also sublimes eventually. So these types of clouds are forming using those CO2 ice and water ice present in the polar areas. So to monitor these, you need a camera which can look at such phenomena from an orbit at a regional scale. As well as we can also do some high resolution studies. This is one example from the Mars color camera, where we see one very odd shaped crater. This is not a typical circular crater what we generally see. It is associated with a catena like a feature. So this catena is basically a large chain of large and deep chain of pits basically. So this crater is called as, due to pits, it is called as a pittal crater, and this was imaged by Mars color camera. So you can take other images of Mars, other high resolution cameras that are orbiting around Mars, and do more detailed studies. Like in this, you can basically, once you identify the catena, you can further take high resolution images to look at the detailed morphology, as well as you can look at the topography data and do a topographic study of the features that you see in this crater. So MCC is not only useful in with respect to the global, it is also for regional as well as very local. And this is one of the studies that came in GRL where the major constituents of the Martian exosphere was actually measured using the spectrometer, the quadrupole spectrometer. So here what you see is the altitude profile of three major constituents, that is having an atomic mass unit of 44, which is corresponding to carbon dioxide, 28, which is corresponding to nitrogen and carbon monoxide, and then 16, which is basically corresponding to oxygen in the exosphere of Mars. And this is showing during the evening time. So you see, the stress has been on the evening side. So there are different activities which are happening during the morning, daytime, and then in the evening and the night time. So this is particularly informing us about the evening time on Mars. And this is again using the main observations. And these were from the 4 orbits of Mars during the late December 2014. So it was launched on 24 September 2014, and then their data was acquired just after a few months. So based on that data, we could measure the abundance of these three particular constituents of the atmosphere. So I hope I am able to inform you all that how interesting was the Mars orbiter mission and what different types of instruments and what different phenomena that we could basically understand about Mars. So with respect to scientific results that came from Mars orbiter mission, we had got to learn a lot about the surface of Mars. We came to know about the exosphere of Mars. Of course, there are certain constraints which are related to the presence of methane, and there are studies that are still going on, which will further, inform us about the present day status, whether methane is there or not, and if it is there, in what condition it is there. Then, with respect to the loss process, whether the water that we have seen on the past on the surface of Mars and how it lost, in what volume it lost, all these things are yet to be addressed. So that's why, as I told you, that Mangalyaan 2 is also in the pipeline. So we are sure that Mangalyaan 2 will be also, achieved in a few year timeline. So stay tuned and let us hope that many more missions will be happening in the future. Many more exploration of Mars will be happening in the future, and we will be able to address some of the very fundamental aspects related to Mars to eventually understand our Earth in a great detail. So I thank you all for giving me this chance to talk with you all about the India's Mars orbiter mission. Thank you.